reality scenarios and digital twins. Last but not least, we'll have with us Veronica Orvalho. Professor Veronica Orvalho is uh, founder and CEO of Didimo. It was a long way since the early days of pure academic research, where I met her firstly when she was working around children with special needs, um, helping them with animations to synthesize emotions and expressions, and she was able to guide her research and build continues a wonderful pipeline, animation and rigging pipeline, and today she has amazing technology for providing realistic avatar, the alter alter egos of the humans in the digital spaces. She will show us a lot about it. So welcome you all, and without further delay, I'll pass the floor to Lionel for his vision on Metaverse, what it was, is, and will be. Thank you.
Thank you so much, Fausto, for this kind introduction and remembrance of all my rotten deeds and problems. Let me then share how little I may have learned over these years, but I will try to be helpful on this regard. So let me go see. So the sharing. There we go. So, this was the challenge that you provided me. So, what was the metaverse? What is the metaverse right now? What can it be? I chose to go after this image from the recent movie Ready Player One. It became quite popular. It was also a book that basically was a self-referential experience, because this book and movie were inspired by a virtual world that existed and still exists today, which is Second Life. The author himself said that. And there are so many worlds around. There have been so many worlds available for people to be online. And this means virtual worlds, so Second Life, the Academia, the Decentraland, all sorts of small games, even on cell phones. But even in the physical world, several years ago, a Google spin-off called Niantic launched Ingress, which basically was this alternative reality overlay over the real world. And now the same technology has been used for Pokemon Go and many others. But before that, we had Sony, the PlayStation Portable, with Invisibles cards and augmented reality games. So we have been blending for many, many years in many worlds.
Yeah, let me see that. 5 cents.
To be honest,
The name's not Pops. I just want to find out about this here parallel.
This is from 1985.
Pops, no playing games. Jimmy, the name's not Pops. Look, I promise I'll pay you as sure as my name is Valentino.
Valentino? What's going on here? What kind of game are you playing, Pops?
Where am I?
Habitat, where thousands of avatars, each controlled by a different human, can converge to shape an imaginary society.
Here's the paper. Intelligent beings muddy the words. Read all about it. Here, have a paper.
Yeah, let me see that.
So that was 1985. I even went to get a TV set from 1985 for your reference. We've been around working with this. That was 1985 with the concept of avatars in virtual worlds. The metaverse came shortly after as a concept in this novel, Snow Crash. This is where Neil Stephenson brought us that idea about this strange city, a city that was a line, a single street that went around the world. Everything was empty besides this street. But it was entirely virtual. It did not exist outside in the physical realm. These heroes like Hero would put the goggles on and see this virtual universe. And the name that was concocted then was Metaverse. Of course, it also explained as avatars were not just our physical representation, they were our means to communicate. They became our interface. This, in 1992, was really the major stepping stone, entirely self-referential, because Snow Crash has been acknowledged as having inspired Second Life. Second Life has been acknowledged as having inspired Ready Player One. And so culture keeps going forward, self-referencing itself and building upon efforts. So for people that are not familiar with why the word metaverse, it's quite simple. It's really, universe is a given, right? But what is meta? You will have known the word meta from words like metamorphosis or metabolism. Or for people who like fantasy, you know that werewolves are metamorphs. So meta is anything that can change, that can become something. And computer scientists usually know this from stuff like meta languages, and even the meta keyword, the meta keyword for compiling. But that's besides the point. So the metaverse is everything, but it can change. It can become something. And right now, everyone wants to know about the metaverse because lots of juggernauts, big tech companies have started moving into the metaverse. They have realized that most likely, as we transition from the desktop metaphor, from smartphones and tablets, into a more prevalent, a more pervasive computational environment, that whomever dominates the new environment will, of course, have a very strong competition-wise position. And so Facebook itself was rebranded as Meta, just to showcase how strong. Microsoft, not only with HoloLens, but even with Horizon Workrooms and other solutions, has been trying also in investing heavily on making this a reality. Now, they arrive at a place where other competitors are already present. And major players are Roblox, of course, and Fortnite from Epic Games. What they have and what the big tech companies, the other big tech companies, because these are also big, but of course, minimal compared to Microsoft or Meta, what they have is users, they have the know-how, they understand the platform. So Fortnite being a one against everyone or everyone against everyone game, or a team against team shooting game, enables building, enables all sorts of events. Like in that case, that image above was because of a concert by Marshmallow inside Fortnite, a worldwide concert. We have all these events and collaboration, and these companies understand the ecosystem, in that this ecosystem is large. You see lots of dynamics. So lots of companies are trying to provide the infrastructure. That's the computational power. That's the ability to connect seamlessly, to connect with low with low latency, to manage bandwidth properly, to distribute computation to the edge. So lots and lots of these infrastructure efforts. Then the human interfaces, trying to figure out how to use the gestures, how to be more comfortable here. The decentralizations, all the decentralization efforts of trying to avoid having people stuck in a place and being able to share all the spatial computing stuff. So it's really a crowded space, an exciting space where people try to understand what's their role. What I provide you to think about is, this is what the metaverse is right now. It's sharded. Every system, every solution typically works on itself with very minimal communication. Perhaps some have federated authentication. Perhaps they enable some joint sharing of data, but they are really separate experiences. And I addressed this in 2009. It was as if we were still living in a very ancient era in the physical world, when humans were isolated in small communities, small villages, small tribes, and mostly unaware of each other. But even so, even in those ancient times, genes would flow. The gene record shows us that. Products would flow, ideas would flow. We can see products traveling thousands of miles across continents, even in that time, and so it is. But what can happen? What I said at the time that I proposed, and I think it's even more relevant now, is that we need to interconnect these virtual worlds. We need to connect the villages and tribes and provide a more global society for these metaverse spaces. Consider this as an exercise in thought. What if we had to use a different browser for each website? For the different software systems, different addresses, go and move and visit each individual virtual space. And this was not very far from what was the computational era before the browser. Those who remember the computing before browsers knew that different applications, different software were necessary. We could not transition. Well, that was exactly also how the internet began. The internet began as independent systems. They were the bulletin boards. Those arrows, just to remind myself of one of my dark secrets, is that I was a system operator of one of those early Portuguese BBSs. And everything was happening at the time. Online games, matchmaking, libraries of files, all was available except the connection, which is extremely limited. The internet connected those isolated villages and islands. The World Wide Web then gave us a visual way to navigate and wander around the internet. We do not have this for the metaverse. It is but a matter of time until these virtual layers, virtual spaces, not only entirely virtual, but also regarding our physical world, get connected. And that they get connected and acknowledge that we move, that you gesticulate, that you have expressions. It is a matter of time, and we have visions for that. This is now even an old concept by Kiichi Matsuda of how you can have extra information changing your livelihood. You can check this on Vimeo and several other online video sources. We have the visions. We have the beginning of these concepts. And the transition challenge is the disappearance of most of the interface. The metaverse will be blended. We will have software applications. We will have virtual environments, but we won't have to see them as applications on a smartphone. We won't have to choose them most often. Most often, in our office, and just our presence there will make it react. The big challenge here is that all of this blending with our world means blending with our global culture. So understanding these global cultures, having the data collections and the data knowledge and insight to understand these cultural meanings and spaces is absolutely going to be key in order for you to enthrall your users, not just enable them to use your systems, but to feel at home with your systems. So this is the metaverse. It's not a place. It's not a virtual world. It's this next generation of the internet, as John Radoff most eloquently said it. It's a decentralized multiverse that communicates, that blends, and that will become, if not this year, if not next year, but at some point in our lives, it will become the next World Wide Web, the next internet. And I hope that this will enable a very interesting discussion now with the rest of the participants. Thank you.
Thank you, Lionel. That was a wonderful introduction to this team. A lot of food for thought. Next, we'll move on to Fridolin Weil, that will tell us a bit about reality adaptive experiences, a bit of the technology, the next step on technology for these environments that Lionel just told us about.
Good, perfect. Thank you very much for the kind invitation to speak to you all here. I'm excited to share some of my crazy thinking and have prepared a few slides for you to walk through with me. Perfect. Good. So I like to speak to you about reality adaptive experiences, which means besides reality, which is surrounding us, experience is certainly a word that needs a bit of a definition. And I thought I'll go back to famous Pine and Gilmore's Age of Experience to explain to you what I mean by that. This is, we have come as society through several ages of experience. The first one, economic ages. The first one is the economic age of commodity, where we look at fungible products such as the one that we see here in front of us, coffee, that can be stored in bulk, that comes from nature, that is harvested and can be sold and has a price, which differs quite significantly from the age of goods, where we look at offers that are produced, that are inventorized, that are delivered, and that differs again from what we've seen probably around the 80s, in particular in the computer sciences, the age of service, where it matters more how something is then consumed and how it is delivered. Here as a perfect example from our coffee world, the endless refill coffee jug that you may have encountered in particular in a US diners, brewed and served and delivered from a provider to a client. In difference to that, today we live in the age of experience. It doesn't mean that all the other functions that we have seen on the previous few slides have gone away. No, on the contrary, they of course still exist. The more significant price building factor, however, in our current economic age is that we strive to achieve meaning in life, that we strive to achieve a lot of memorable experiences for which we're willing to pay, for which we're willing then to treat ourselves with something special. So in the context of the coffee example, it's the celebration of coffee with a barista who mugs up for you a Harry Potter froth on your cup of coffee. The difference to the other ages is also in the wording. For example, we speak in this context rather of a guest or participant and an experience being revealed over time. Imagine that more like a workflow. Yeah. So the striving that we have in this economic age is quite certainly a question of memorable experiences. So when I speak about reality adaptive experience, I speak about this shift in mindset as well, that creators of experiences need to shift away from the thinking of having users to rather guests or participants, away from how you use and utilize an application, more into how can people live in your application, how can that application blend into the Lebenswelt of the people surrounding them. Yeah, if we now look at what that has as an implication for our augmented reality, then maybe we can summarize that big progress has been made, and that I think motivates a lot of what we hear today about the metaverse, but also about all the related technologies. It is a market. It is a market where hardware is out there that people can use. In the case of, I would almost say, mobile supplements for the real thing, this is a significant market, predicted to reach in 2 years' time about 1.7 billion active mobile users / devices, actually, in that case. But even when we talk about the kind of real thing, the headsets, it is slowly evolving into some sort of market. If you look at the numbers of devices being sold year after year with exponential growth here as well, it is slowly amassing to something. And we may be a bit special as the distance teaching university of the UK. Amongst our own student population, almost 8% of our students claim that they do already own a virtual reality headset. So certainly something that makes it possible to invest and makes it possible also to commoditize, develop horizontal services and whatnot. If we now look a little bit more at where the technology stood up until the metaverse seems to be changing everything, then maybe in the past you would have heard about marker-based versus markerless augmented reality. I think that's a bit of an imprecision maybe, and I'd rather speak of image-based versus spatial mapping augmented reality. And that's how today quite a lot of the prototypical applications you would find out there are being built. They're built on the principle that either you use computer vision to detect flat images or segments of images, if you're taking it to the next level and try even to detect which side of an object you're facing at. Nevertheless, still relying on flat surfaces, versus the more, coming from the world of simultaneous localization and mapping, SLAM, the point clouds with which we can sense environments surrounding us, relying on more modern sensors such as smaller and smaller RGBD cameras, depth cameras, or LiDAR, as in the new Apple devices. Differing in that respect, that they are no longer reliant on flat surfaces, but rather try to pick up on the physicality of the environment in 3D space, really. So that's the past, and I want to make a few examples to illustrate how powerful that already is and why it has triggered this revolution that we're currently looking at. Image based means originally using highly optimized pictures, such as you see here on the left, markers. That's kind of the end of the 90s, 2000s technology, still in use, of course, today, especially where it matters to detect things fast and from a distance. We see these black and white pictures that try to stick to rather geometrical lines that are easy to process with computer vision or other related tech, and differing, however, significantly from the more free-form image targets that become more prevalent in the years up to now, with, for example, Vuforia being one of the SDKs, the software development toolkits that are certainly leading in that market. Difference being image targets are free flow and you can use them as you please. Whereas with markers, you're more restricted and in that black and white world. Powerful nevertheless, because with image targets, you can anchor things in space. So in this little example, and I'll play it again here, a Halloween joke many years ago, we trained a marker or an image target on that poster that you can see there in the background, and then use that as an anchor point to put that skeleton there. And that allows us then to do quite a range of things in interaction. So first of all, we can measure the distance that the spectator using smart glasses or using a mobile phone has from the marker from the image target. We know exactly how close you are, or well, not particularly precisely, but close enough that we can do range-based activation, as you see here in the example. Walking closer to that poster allows to activate a trigger. That trigger then makes the skeleton lash out, and that in return makes the user, in that case a younger version of myself, react the way I do. An experience revealed over time, trained on rather simple technology that is not even that visible. So at the time, that meant calculating the sizes of the poster and figuring out from what distance it is actually visible in the smart glasses, and that is slightly different as a technology from the spatial mapping-based technologies. So the spatial mapping-based technologies, here you see a revisualization of a hotel room in your neighboring country, Spain, some time ago. I think this was in Barcelona, filming what you see from a LiDAR scan when it's reconstituted and colored also with the color information available from the optical video camera, combining that here onto this spline, onto that mesh, and then mounting a camera now through it, so you can get a bit of a sense of depth in this two-dimensional recording of a three-dimensional scan. So you can almost see that it's my mail client open on the notebook here of this spatial map. This is a slight generational change. The research underlying this has happened probably 2 decades ago or something the like, and took a while to get that into devices computationally powerful enough that they can calculate pose estimation on a mobile and work actually with that spatial map. I think Google Tango was one of the things that pushed things quite a bit forward, but there were others. Recently, I think it's Microsoft and the world-leading development around the mixed reality toolkit that is exemplary here and in this context. That makes other services possible, such as what you see, for example, here. And let me just make it sound off. Here you can see a recording of what we call a ghost track. So it's a spatial map to map out the physicality of the environment. You can see here the walls being scanned and represented with these dots, and the floors, and one of the possible Mars rovers that one day may go up on the surface of Mars. The indoor position of the person actually doing this recording also the voice of the person, and you can see here then a reconstituted visualization of this recording, of this indoor navigational path that we call a ghost track. So you can see here, and I'll jump back to that replay. You can see here then the female version of the ghost walk around, walk and talk. Well, you can't see that now because that's clipped from the video, but providing some sort of explanation. This here was recorded on a mobile device. On the smart glasses, you additionally have access to hand information, and you can see the hands pointing at things and showing how to do things, and that's all terribly exciting. The overall interesting possibility here, however, is we can work much more precisely with the environment. The stability of projections of holograms into that space is much, much better, and no longer reliant on calculating the right size of the poster or coming up close with your mobile device to the piece of paper and then zooming back and hoping that you don't lose tracking. That's a thing of the past in this approach, and typically applications these days use an approach of both to achieve more interesting things and use also the stability of the indoor navigational mapping that a spatial map provides, so that holograms don't jitter and jerk around depending on the tracking engine losing sight of the object it is tied to. Yeah, limitations, however, of this approach are, if not combined with the marker-based approach, that it's tied to one single location, and that is, I think, where the interesting bits set in. That's, I think, where the state of is not only research and development at the moment, where we're gearing up for the future, where things can be reality adaptive. And I think that's worth pausing a second and explaining that a little bit more, what I mean with reality adaptive. It deals in particular with this problem where you need to cast one environment onto another, where you have recorded something in one classroom, for example, but you need to execute it in a second classroom, or you have provided instruction to do a maintenance operation in a helicopter base in one place, in one particular hangar. And since it is the same type and model of a helicopter, though with a different number plate, you would want this to be executed in a second location in the same way, adapting to the change in locations, the change in points of interest, and maybe supplementing as well room-defining objects or other types of objects, such as tools, with their closest alternative if the one for which it was originally construed is no longer available. Similarly, adaptive means adaptive in time, that it can respond to events that are happening in the surrounding, being sensed or observed, or communicated also through Internet of Things technology, and planned for through embedding of triggers in the interaction scripts. So that may now be a bit much. As said, think of a simple example, like here you have an Augusta Westland, I think that's a 169, if I'm not mistaken. It's one type of a helicopter. If you have a maintenance operation such as change the tail rotor blade, you would want that to work on any of these models, possibly even if it is a model that is slightly modified, which does happen. Customization in the market of expensive things is definitely a thing. And you would definitely also want this to work no matter whether the coating of the helicopter here is with ambulance colors and rescue versus if it is a civil helicopter. And moreover, you want this to work in any of the operating bases where such a helicopter could land. And as you can imagine, those are many. So that's the challenge, basically. And for that, we have developed in the past a standard in the IEEE that is since 2020 now a fully fledging standard. It's called ARLEM, Augmented Reality Learning Experience Models, although the L, which is the context where we originally developed it for learning and training, L can be spelled quite small, in my opinion. And the applicability of this is more widely for experiences in general. We have foreseen in that context that we split the kind of world knowledge that is required for reality adaptive experiences into the workflow element and the workplace element. So one we call activity modeling language, and the other we call workplace modeling language. They describe, in the case of the activity model, a sequence of action steps. First do this, then do that, then do that, that sort of stuff. And in each of them, a combination of where this happens, to which physical object or location it is tied, and what digital overlays or other types of augmentations might be switched on or off. In case of the workplace model, that's more about the kind of reusable elements that matter for more than just a single activity you would want to execute. The workplace model contains, of course, locational information where locations are fixed. For example, in a hangar, the door where the airplane or the helicopter flies in is certainly always in the same place, unless an accident happens. And a toolbox, however, may be more movable, but could be detected through the use of an image target that is stuck on the side of the toolbox, that sort of stuff. Workplace models also contain then sensor information of like how to read something from an Internet of Things enabled device. Here's an example of the JSON binding of such a rather simple activity. This here is a kind of simplified version of the rover scenario you have seen before. It contains a bit of metadata. It says with which action it starts. The first action activates at the beginning on the point anchor 15 of the rover, a so-called ghost track overlay, and there's some additional data file available that contains these indoor locations, how the ghost moved around and where the hands were. So that's a rather simplified model of a one-step activity, but I think you get the gist of what that means. Of course, in reality, this can be then a much more complicated sequence, also with branching and dependencies and parallelization. The interesting bit is probably here in the triggers. That is the point where, when I spoke before about reacting to events in the environment, that's where the magic happens. For example, if a button is pressed and that button press is communicated somewhere on a message bus so it can be picked up like a sensor, then that can be used to trigger a certain branch of an experience, or whether something is visible and the user is standing close to it can make a difference and can activate something. And in some cases, you want these auto-completing user elements and so on and so on. This, however, can go much further. So especially when we talk about activity instruction on how to operate specific machinery, how to do a maintenance operation on a helicopter, this and that, more and more linked data is available that tells us how objects are related to each other. Linked data that semantically describes what we have available products-wise can be utilized to gracefully degrade, for example, or find worthy replacements for tools that are available in one place but not in the other. If you're thinking, and I think this here is the example of the maintenance operation, and it might require a drilling machine, then which of course it doesn't in that case. You wouldn't drill into a tail rotor, but for the sake of it, bear with me, let's stay with this. If you would require a drilling machine, but your original instructor would have created this scenario using a Bosch drilling machine, the next close alternative that is available in the place in which it is executed is a DeWalt drilling machine, which are pretty much the same, just that certain small locations may be different, like where the on button is exactly located. Then this slowly becomes feasible in our context, so that we can harvest, for example, here from a specific schema that describes product catalogs. So that's GS1, that's the kind of semantic format that is very close to the barcodes that we know from any DIY supermarket, online retailer. That's in the making and becoming increasingly available as well. And that is, I think, where some of this reality adaptive experience will draw its power from in the very near future. That means then for a world in which we deliver a lot, which minded we do at the Open University, we are gearing up for kind of the next big thing. What if AR, VR, if the Metaverse and related technologies are ubiquitous, if they're everywhere, if they're part of anything we do, then that means also that we need all types of different databases that make this adaptation possible, that help us create content for it and support our other academics in creating the learning offers that we want to get out there. Yeah. Right. So if I try and summarize what I'm talking to you about, I undoubtedly believe we live in the age of experience. Whether I fully liked it or not, I'm not always 100% sure. Certainly, a lot of our economic offerings circle around the idea of spending our life at the best way possible with lots of memorable experiences. And subsuming and replacing, but also incorporating earlier economic functions such as agrarian, product-oriented or service-oriented economic functions. That taken seriously means a paradigm change in the way we design augmented and virtual reality applications, and that means in particular that we celebrate this element of being a participant rather than a user, and have to think about how we tell stories with the medium and plan that well. And that in almost any context I can think about means we need to reveal kind of activity-like structures over time tied to the location where it is actually delivered. If we then look at the technology, then in the technology realm, we can see that we may find in the past a lot this marker-based and markerless, or better image-based and spatial mapping-based augmented reality applications. They are certainly technical waves that have happened. They are not enough to make the metaverse, to make this alternate reality that can surround us happen. To make that happen, what we actually need is reality adaptive experiences. We need the possibilities to make sense of these lower level services. We need to make use of them. We need to use the computer vision capabilities to detect flat surfaces and their extensions that are in the making for 3D objects, as well as the mapping, but complemented with spatial understanding so that we can figure out where in this room the door is and what tools are lying around and whether I have an intercom here, so that we can deliver the right experiences, but adapted to the actual user surrounding. Only then, and only then, I believe, that we will have these network effects that we have seen for other waves of media in the past. Only then it becomes possible that content created for one location can almost seamlessly, probably fully automatically in many cases, be converted to a different users surrounding, delivering a similar experience there or an identical experience there to what they would have had in the place of design. Yeah, and that means for us technically three bigger things. To treat reality as a medium, we need to find new ways to link across space and time, and that means in particular we need to continue to improve the capabilities for sensing and experience capture. Means, of course, increased use or continued increased use of artificial intelligence algorithms for refinement, validation, extraction, sense making, so that we can make sense of captured stuff and pave the way for adaptive visualization, adaptive interactive visualization in XR. And only when these come together, they reduce costs, increase speed, empower horizontal services, and make the network effects possible that everybody in the wider industry would like to see. Yeah, since I've been so speedy, I do also take the liberty to, in this context, and then again, not shamelessly advertise our new incubator that we're pulling up at the Open University of the UK, open to anyone across the world. with almost no strings attached. We provide for educational technology projects and startups, and that includes the ones around the metaverse or AR, VR. Some seed funding to help with this initial phase with up to £50,000, where we fund in a two-wave process, in a two-phase process, with the aspiration to win 50,000, at least the 5 to 10,000 that are requested in phase 1 to 6, 2 times 6 projects in 2 waves, and another 40 for a smaller number of projects, possibly more if we can, and try to make it work. Also with the strong aim that we help startups in this area of edtech and also in particular in this area of extended reality to get a foot on the ground and move on to more significant investment. And the deadline for this is March the 1st next year. Yes, so if any one of you has an interest, please approach me, and please Google IET EdTech Foundry to see more information about what this is. As said, I'm delighted to speak to you about reality as a medium, and very much look forward to the continued discussion amongst us and amongst you, the audience. Thanks.
Thank you. That was really refreshing, and at the same time, we are near those things, and yet so far away. Okay, thank you, Freeline. Now we will move on for our last guest, Veronica Orvalho from Didemo will tell us about our wonderful Didemos and how they are made and how they are becoming. The floor is yours. Thank you.
Thank you, Fausto, so much. It's with a complete delight. I'm here today with all of you. I'm going to try to share my screen. So hold on. Oh, no. It says I need to update a driver.
Ignore that. Usually works still.
Really? Okay. Let me try again then. Let me see. I just put my full screen. Do you see everything?
Yes, we can see it.
Yes. Great. Let me put it full screen. Do you still see?
Yes.
Yeah, fantastic. All right. So thanks again for the invitation. It's about 20 minutes, right? Because this finishes at 4. So it's questions and answers afterwards, right?
Correct.
Okay, I'll do my best. So great presentations before. My presentation, I'm going to try to focus it more on the technical aspect of it, and hopefully you find it interesting. So a bit of context before I start. This is what Fausto was sharing before, is the story behind Didimo. So I started researching on creation of digital characters maybe about, I don't know, 15 years ago with my PhD, mainly understanding how we can automate the character creation process for film and game and game companies. And then something beautiful happened, which was this project, which was called Life is Game, developed at Porto University Instituto de Telecomunicações with Microsoft and UT Austin. And we did parallel projects with Fausto at Altice Labs, all of them around understanding how kids could improve their communication skills by drawing and mimicking facial expressions on digital characters. And the picture that you see on the screen really changed the way I used to do research forever, because I was very gaming and very techie. And then suddenly I discovered that we could actually change the life of a family. So in the screen, we see Joao and his father, and he suffered from severe autism. So he couldn't even actually use the application very much on the screen. But so his dad had to help him on how to draw the expressions on the digital character with the hope that in that way he would express how he feels. But what was amazing was that after many hours, this happened. And it was one of the very first times that his dad actually saw his son so engaged. But then something even more remarkable happened, which was, this was in 2010, when the tablets had just came out to the market. So there was not even an app store. So his dad asked if he could take the tablet with him. And so, as we do research, I asked him why would he wanted to use the application instead of his son. And he said that it was because he was going to draw on the characters how he felt in order to communicate with his son. So that was for me kind of like this huge, aha moment where you suddenly have a technology on your hands that you had no freaking clue, the power that it contained. So I'm not going to explain everything that happened from 2010 till 2016 that we created Didimo, but what did happen was that I started to research on new interaction models. How could we use digital humans as a new interaction model, as a new interface? So if we think about it, every 60 seconds, thousands and thousands and millions of people are trying to connect in some shape or form. Either they send an email, either they send a tweet message, snapshot, they create a TikTok, however. And the truth is that none of these connections actually allow real-time interaction between one person and a system. So what I end up researching was, okay, which is the most human way that we can interact in the future when we are in immersive applications. So people would call me crazy when I said it was going to be a digital character or an avatar until the pandemic came up and suddenly people use avatars everywhere. So we still want to focus very much on digital humans that are more human-like, more photorealistic, that they're not like creatures or cartoons, even though those can be an extension of your identity as well. I really want to focus on more human-like characters because that's the ultimate way on how we see ourselves represented and we can build authentic connections. Because if we create our Fortnite character or our Roblox character, we can always delete it and it's gone and you can create a new identity. But once you see yourself or a representation recognizable of yourself, then it's much more difficult to delete that authenticity on the virtual world. So up until now, this is the motivation, right? And then what are the business opportunities that creating these digital humans bring to the table? So again, up until recently, a few years ago, we would have the entertainment space, the retail and shopping, and then the working space or social, kind of like three silos. So each industry, trying to do the best they do on their own spaces. And now suddenly, in the past 2 years, what we start seeing is that all these three industries are kind of like coming together into one unique place. We can call them metaverse if you want. But the truth is that now you can actually be playing a game with your Gucci t-shirt or your Balenciaga outfit, or you can go shopping online with your own digital self and start trying on different garments. So these are the new opportunities that the market is seeing once we put a digital human in play. But it's extremely difficult to do, and that's what I'm going to explain you how we do it. The goal is to create digital characters that in a very, very fast way, when I say fast, is like in less than a minute, in a very scalable way with no human interaction or artist having to touch that character, and in a way that it can be affordable. Because I believe, and this is just my opinion, that we're all users of these virtual worlds, and eventually we're going to become content creators in these virtual worlds. So that's, again, a big opportunity for everyone that is using the internet and building new technologies. Just think about the end consumer and the end user that is not just a gamer any longer. It can be a content creator. Maybe someone that buys online is not just buying, it can be creating content as well. So how can we create the tools around these immersive experiences where the users are much more than just the user? Okay? So this is a bit of the motivation. So what we do is we upload, in this case, a selfie into our cloud, and we can automatically, in less than 60 seconds, the fastest we can do is 15 seconds, depending on the configuration of the digital character, automatically create a digital asset, which is, in this case, recognizable by the user and embedded automatically into a metaverse, a game, a virtual try-on experience, you name it. In this case, it's with Atom Stars, which is a company that they create metaverses for different industries. So just to give a little bit of explanation on how traditionally you would create digital characters, and AAA games and Hollywood companies, they still do that. Creating a digital character that is very photorealistic can take hours, weeks, and months, depending on the complexity of that digital character. And usually game studios or film studios, they do manage today to automate part of the process. So we have, different stages to create a digital character, which is very, very sequential, like modeling, texturing, rigging, animation, and shading. And on the right, you see some images. So for instance, on the top is Cubic Motion that created an automatic system for motion capture that is very sophisticated. And in the bottom, you have the lightning stage, the first lightning stage created by Paul Devebeck and his team, that allows to do photogrammetry and create also super high quality digital characters. So you can see the equipment is expensive and definitely not user friendly. And even if you could use off-the-shelf software and hardware to create digital characters, if by any chance you need an artist or an engineer to manipulate or change something within the pipeline, it just is not scalable any longer. So what we have been, or what I've started researching, many, many years ago, like with my PhD, I automated the rigging process, for instance. So my goal was, okay, very insane. It's like I wanted to automate the whole thing. And that's what we managed to do after many, many years of research and development. We created a very consolidated engine that puts all those stages all together. And we did keep a very modular architecture, because there are two things that usually the companies or the artists or the developers want to keep ownership when they create the digital character. They want to keep control of the morphology of the digital character, that means the geometry, and they want to keep control of the behavior, how it is going to move. So that's about in the rigging and in the animation step. Sorry, and third, the other thing they want to keep control is on the style. So how does that character is going to look at the end of the day when you render it? So we put a lot of effort into, if we work with a company, that company can give us the specifications of how they want that digital character to be in terms of morphology, in terms of behavior, and in terms of shading. And we then set up that into our engine, and we then automatically create a standard file that it can be in FBX format or GLTF format to give to the company that's going to be using our assets. So they never see this complexity. They just input a photo or what we're working on in prototype, that digital character to be, and then automatically we output the file. And we can process thousands and thousands of digital characters at the same time. This is currently running in AWS servers, but it can simply run in, for instance, in Azure or other services as well. One of the key things that I find out that was really challenging, I thought that when we created Didimo, just creating the engine was good enough. Just, okay, we just can automate the digital characters and that's good. I then realized that that wasn't enough. We needed to create a lot of tools around our engine so developers and character artists can actually interact with our engine. So we spent about a year and a half to just create additional tools like interfaces for our API, Unity's SDKs and scenes, the same with Unreal SDKs, everything that a developer will make it easy for integration, because otherwise, they needed to code a lot and they would not use it. The other things we experimented was, okay, which was the best input data to generate that digital character. So we have technology to, of course, do the selfie, to do more high definition photos, or even to do photogrammetry with a mobile phone by capturing a point cloud. What we find out is still today, the user interface or the user experience that has less friction for an end consumer or an end user is the selfie, even though the scanning with photogrammetry or with point clouds provides even higher resolution. So users are willing to sacrifice a higher, more accurate version as long as it is easier to use. And that was a critical learning. And again, always letting the artists and the producers and the art directors really have ownership over morphology, behavior, and shading. Okay. And if we look about the costs, we pretty much took a production. If we look at one of the characters for a FIFA or for any big production, it could cost about $500,000 to $1 million just to create one digital asset. And we streamline it for like less than $2 to consumers. The costs are much, much less. So even from a cost point of view, it's much more reasonable. When we talk to users, the other thing that was interesting to learn is that by default, they assume that you create digital humans. So therefore, the actual problem that we're solving into companies is that we're really fast, and we're really cheap and at scale. This means that we save companies a lot of money when they need to create digital characters, in particular non-playing characters. So that's what the companies are really looking for. They assume that you produce a good asset, and then on top of that, they just wanted to make sure that the key value that we provide is, reduction in costs. So I'll start, I will touch a few things on the technical points, and then you can ask me more questions if you want. It's very difficult to explain everything that we have. We have about 19 modules that run one after the other to create the digital human. So I'll just explain a few. And the other important thing is that we re-implemented everything that third parties or external libraries would have. So we own every single line of code that we have in the engine. And that is also very important when we're talking or working with bigger companies, because they want to run everything internally and they don't want to have any issues with external libraries. So for example, it took us about a year to take out Maya as a back-end library that we were using on our software. That's just one of the many examples. What you see here in the screen is one of the hardest problems. The hardest problems are illumination and hair, okay, for us. So I'll explain, I will touch on both. So in this example, what you see is that we take a selfie, and we have different algorithms, most of them on computer vision algorithms, that what they do is they go through the image and they clean up all the artifacts, and artifacts are specularity, shadows, the different levels of contrast on the image. So we have to clean up everything that comes from that selfie and then automatically create a set of textures that would allow, when you put them on an engine, to produce good quality. And in this example, you have different illumination setups and both DDMOs. We call it DDMO, which means a digital twin in Greek. So you have a DDMO that can be nicely rendered despite the illumination. And this is being rendered using the high definition render pipeline from Unity. Another key thing when you're creating digital characters is how can we retarget and create fast animations. So here is an example of using the AR kit on Jim, and he's doing the animation, and we are automatically retargeting to a different model with different volume. Okay?
Hi there. Let me introduce myself. I am a Didymo. I'm created from a simple 2D selfie, but I'm a 3D digital double, a digital human.
So in this case, it's just to show how we can quickly create animations. And as we imported, we use the AR kit with the mobile phone. We could also use the TTS of Amazon, cognitive services of Azure, or any AI-generated synthetic audio that it will play correctly. The reason it will play correctly is because we have a visual animation system for speech that can translate input voicings that are recognizable or triggered by the TTS or by the audio. In this case, what we're doing is different with the motion capture. What we're doing is we're recognizing different points on the face that then will trigger our facial deformation system. So we can do both things. Okay, this is part of a demo that we did for GDC, for the Game Developers Conference, and part of our Unity editor that people can use. And what I want to highlight here is how the digital characters are all different in morphology and they adapt to different illumination systems.
Okay.
Sorry about the audio, too loud. But this is part of what you could find on the editor. So you can actually see how we can put any illumination setup and it will play correctly, and all the faces adapt to the actual morphology that comes from the 2D selfie. The system is also prepared in terms of body. These are our older bodies. I have a new ones further down. And the bodies, they come fully rigged, and they are already compatible with like Mixamo, Rococo, any other motion capture system that you might think of. Oops, okay. So the way the animation works, probably is the easiest thing to do body animation, or at least for us, compare when you do faces. So one of the things that we needed to take into consideration is the skin color matching. So the pipeline for the bodies is you take a selfie, you generate the DDMO, and then you automatically stitch it to the body. You have a predefined rig, and the bodies are deformable. So if we're working with a fashion company and they need to have different body size, they will input those body size into our bodies, and we can deform it as well. And then we do a skin color matching process to the whole body. We have predefined textures for the body, and then we can adapt the skin color based on an average of colors that we take from the input photo. Through our API, all this is accessible, so a developer can use our API and can make different calls to extract the different features that they want to use when they develop their own applications. And then as it is fully rigged, then you can map it into any, using Mixamo or Rococo to play back any animation. This is just to show, that we throw, I think it was like about 200 digital humans in a scene. And we can see that the scene works correctly. This was part of our tests to make sure that it will run in virtual worlds. One of the key requirements that people would ask us is, can you just have a lot of your DDMOs with that quality inside virtual worlds running simultaneously? So this is part of one of our performance tests in terms of body for crowds. I mentioned a little bit about bodies. So the way we created the bodies is we created a male and a female body. Apologize that they're completely naked, but that's how we put them out. And we have a deformation system, so we have the body broken down in different pieces, and using a blend shaping technique. If we input body measurements, we can automatically adapt and adjust how we want the bodies to be. So, for example, we have this integrated with Browseware, where we tested their body deformation system, and so the users within their software, they can manipulate the body measurements and automatically create these different type of bodies. One of the hardest things to do is hair. We haven't really cracked down how to really solve hair. So there are different ways to consider, and if there's anyone in the audience that has loves research, this is really a hot topic. How to actually make hair grow from a single selfie. So that would be my call to action to anyone in the audience that's willing to do some really hard research. As we do not have time yet at the company to dedicate on doing hair to grow, probably we'll tackle it at the end of next year. We created a hair library, and we have different resolutions of hairs. So this is what you're seeing here is our high definition hair. This would only run on like an Unreal Engine or a Unity, but it will be more for PC or PlayStations or Xbox. It needs really strong processors. They will never run on a mobile device. Okay, so for mobile device, we had to do a different technique. These are hairs created with strings, and with mobile devices, we use cardboards, and we do low resolution hairs, and I'll show you next. So we had to spend a lot of time just to create these hairs. So just to give you an idea, each one of these hairs, one hair will take about a month of just one artist. Okay, just to create these really top state-of-the-art hairs. Okay. as we do not have a month to spend for every hair, and creating hairs are very, very difficult, we needed to come up with a more creative solution. And so we implemented an algorithm that I will talk later, which is called the asset feature. And I will tell you what it is in a minute. In this case, when MetaHuman came out, we were really, really excited. So what we did is, and with Mesh for MetaHuman came out. So these are renders in Unreal Engine, and we created the selfie with a Didimo. And we automatically place some of our hairs, and we pass it through the MetaHuman engine, and we can create MetaHumans really quickly from a selfie. So we pretty much can create your personalized digital characters that are compatible with the Unreal Engine and the MetaHuman engine, or you can just use ours directly into the Unreal Engine. Okay. And Unreal, as you can see, can really animate hairs very nicely. Unity is going towards this direction as well, but not yet fully available. As I mentioned, when we were doing the hairs, we realized that creating content is a very big pain point for companies. So what we did is we created an algorithm that we call the asset feature. So we don't want to be a studio that creates assets, but we want to make sure that content creators can access our digital characters and personalize it as they wish. So what, at the end of the day, what we want to do is become the best digital human technology and the easy destination for anyone to create the asset itself, like the naked asset, right? And then, as I mentioned before, based on my assumption that gamers and end consumers will become content creators, we give them the tool set so they can place any asset on top. So I think what I'm going to do is, because I think we're running almost out of time, and I have use case if you want to see, I'm just going to stop this presentation and show you a live demo of what the asset feature is. So hopefully that will work. So bear with me for a second. Do you still see my screen?
Yes,
right. Yes, great. So this is what we have in prototype. So if you go to our customer portal and you create a Didimo, you will see the Didimo with some basic garments. And this is what we're going to be launching next. So it's the ability of creating pretty much the naked digital character. Okay, so this is our current version of prototype, and it doesn't have eyebrows, it doesn't have anything. And then you can create a Didimo on our customer portal, and as this is a prototype, I already have many that are already created. Okay, so as you can see. And then the coolest thing is that, and they're full body, so they come, fully rigged, full body. You can animate them as you wish. And the cool thing is that now you can start, you can change skin colors, okay? You can then actually understand that the face itself has full assets, so the eyes are proper eyes, so you can actually manipulate them even individually if you wish. You can start putting assets on top of it, and those assets are not created by us. So if we go to a company and a company has their library or their marketplace of assets, we grab those assets and we can automatically place them in the digital character. So if I go and I switch digital character and I choose again the glasses, they will still fit correctly, okay? So pretty much one of the things that we've been validating is that this asset feature at the end of the day is crucial for scaling and making content creation really fast. We can put makeup on it, and all these are actual 3D features, so not created by us again. And if I change another digital character and I go back and I do the makeup, they should adapt correctly. Okay. So this is where we think the concept of digital technology or digital characters are going to be moving forward. And I think I won't have time to walk you through all the use cases that I had, but I'll stop here for questions unless you want me to show you anything. And this is the team behind it. So we're about 26 by now in a Didimo making it all happen.
Thank you, Veronica. I think it became quite clear for most of us why Didimi has been so successful lately, raising huge amounts of relevant investment.
Thank you.
Congratulations for your progress. It's amazing. I have following it, and even so, I'm surprised each time you show what you are doing. Okay, so we have now a moment with about half an hour for our honorable guests to chat a bit about these topics. I think it was a set of wonderful presentations, and I'm sure Lionel will guide us through nice topics to explore. I think we still have the chat open for questions, but the question that put there have been already answered, but feel free to participate there. Okay, Lionel, Fridolin, and Veronica, floor is yours again.
Thank you, Fausto. Thank you, Fausto. I love these presentations. We've known each other for so many years, but it's still coming at the same stuff from different perspectives. It's great. So Fausto actually was kind enough to give me a crib sheet of some topics that Altice is interested in, and so without any shame, I'm happy to bring them about because I do think they match what we've been presenting. And one topic that comes to mind, Veronica just finished with this ability, the same option to have these accessories coming from different companies, this blending of different sources, which was where I started. I started my presentation with the need to break the sharding, bring the shards together. So how would you see the current challenges of having this interaction between not just different company sources, but different data sources? So we have the physical world to map to the extended reality components, as Fridolin brought about. We want that to be interpreted in a semantically higher level so that we map that to the virtual reality like avatar. So let's make this more concrete. So for instance, Veronica, how would you help, let's say that scenario that Fridolin showed, where there was just a torso, a phantom torso going about. How would both of you, the current status in trying to make that torso more real in terms of what really is happening? And let's start from there.
Yeah, in our case, the way we do it is we talk to the customers and they provide us with the specifications. So we can give through our API the head with the half of the body, the head with the full body. So they pretty much go towards an interface and they can handpick the specifications they want. We do more photorealistic type of characters. So we already have embedded on the assets the different textures in order to do skin color. And what we are going to be releasing in the next few months is the stylization of it. By stylization, I mean the company defines the style visually. They give us the style, and we automatically create the shader. So then when the characters come out, they will just follow that style. So yeah, so we're creating an algorithm that pretty much reads styles and outputs the different textures to match that style based on the customer's input. That's how we're solving it at a very high level. Then you talked about semantics. We can either input a photo. So we have an algorithm that is called the deep predictor, and we can create synthetic data. So we can create synthetic data 2D or 3D. So we don't need anymore to scan hundreds of humans in order to create a database. We can create it synthetically. And by creating it synthetically, we can also label it synthetically. So the next step that we want to launch is what we call meta descriptors. People will be able to say, I want 1,000 digital humans with this style, and I want them with blue eyes, with dark hair, with wrinkles on the face, no wrinkles, whatever. And then it will search into our database and it will create the digital asset synthetically. So that's what it's going to be coming next of what we're doing. Yeah.
It is very exciting. So of course we have been discussing for Mirage also to interlink with services such as yours, and that is exciting. And we should users want this identity element. They want to be visible, and I think if we're envisaging a future in which people browse through each other's reality streams, you live stream from other locations, but it gets reality adapted into your space, that would be terribly cool. And I think one crucial part of that is the ability to shape up your representing avatar or character model in the way you want it. Something that looks like you or as something you want it to look like. That necessarily has to be the same. But I wanted to move us onto a different path and raise a point that we had been asked some years ago by a reviewer of the European Commission in one of our research projects. And the question we got was, would you want a photorealistic avatar or would you want something smaller? Would you want a person or would you want an animal? Would you want something that floats on your shoulder and whispers into your ear, or would you want something that stands by the side of the object? And there is a bit of work academically around that. So I'm aware of some investigations that look into how do people perceive, for example, instruction. If you have a character model instructing them, where do they need to stand? Ways of maybe automatically deciding that they're not in the way. But I don't think that we found the one size fits all or the principles yet, I think, as a field that explain where to best use these. And I think there's still more experimentation needed. For what we had been thinking about in the context of our goals, the transparency mattered a lot to us. This idea that you can step into the footsteps of an expert and look at things through their eyes and mimic their body movement is quite important. And for that, it has to be transparent. It can't be photorealistic. And then again, that's probably not really where technology is fully at the moment. There are some interesting findings from performance coaching projects like Holodance that were looking into what do you need to do if you instruct professional dancers into doing the movement as they want to do them. It's not yet there. We don't fully understand everything, and there is more to it than just the user representing element. There is a question that we need to ask ourselves in that context of what are we using this for? And I think it still needs more experimentation. But it's terribly exciting, and I see that you're having a lot of fun. You're playing a lot with these tools too. It's getting somewhere.
Well, I would like to bring about that we have the input, yes, collecting all this data and rendering it, and then the output, the rendering it. But we need to be able to transmit it and to connect it. We have an audience here due to Altice being a communications company that is quite concerned with the technology like 5G, edge computing, all these kinds of networking. And I must say that we do have some concerns there in terms of the technical challenges that we overcome in terms of interoperability. And why? Why? If you consider, for years, we have been discussing on the need to have new ways to organize teams and companies and schools and that do not want to basically sit down on a rigid schedule at a rigid moment and listen to each other because it's extremely inefficient. So this has been going on for years. In schools, everyone wants to do active learning, but they can't. Mostly they fail to do it because they're not there for awareness of what's going on when it happens. So it's extremely time consuming. Everyone tries to move it into, it was Scrum at the time, now even new methods, and to say, let's just keep meetings to 15 minutes, quick shut down and go. And the consequence of much of this is that there is a challenge of awareness of the team. People are not, when we are doing this kind of thing of having the avatars there in real time or taped in real time, we are only solving part of the problem. Because if you need to be there and wait, like watching a 3D movie, wait until everything is going, it's not scalable, it's not manageable. So we need to have data analytics that tells us, look, for instance, again in the rover, but it could be in a work session. Look, over the past day, the meaningful events that happened here were these for your perusal. Or the categories, the patterns of events, the patterns of behaviors. We called it at Inesc Tech, we call them virtual choreographies. Meaningful patterns of events, of sequences of behaviors and events. The meaningful patterns that happen here are the following. You can show them to you, we can analyze them, you can realize what's going on. And so suddenly, if you have that kind of solutions, you can go beyond that real-time, time-consuming experiences and try to give new solutions. This requires a lot of attention. So we need new ways to interoperate with systems. We need data collection, data that can happen in distributed ways. So I do think we have challenges there because we neglect these deployment aspects. These are deployment aspects. And I pass on the conversation.
That comes from a musician who celebrates life experiences. I just wanted to throw that in. I think in some respects, I agree. And I have meetings like that too, where you think, okay, couldn't we have done that in 5 minutes rather than in an hour? It happens. It's life. At the same time, I think if you do it well, then the life experience, there's nothing greater than the life experience of seeing something choreographed, work together in unison, without dissonances that are unplanned. I think that's having the possibility that we can reach across space and bring people together that otherwise would see each other only every few years or not at all. That's fabulous. And maybe like other social media, it depends on how we use it, whether it will turn us more egoistic and hidden away in bubbles, or whether we use it also to expand our horizons. But I'm not sure that technology has an answer for these problems. I think it's more a question of how we deal with it. And yes, sometimes we cut some of these meetings short. And yes,
Veronica, your microphone.
Yeah, thank you. I can answer one of the questions that is on the chat, which actually touches a bit on what interoperability is, and we were talking a little bit before. So we work really intensively, and our decision was we want to make the output a standard file. So that means that we don't really define interoperability, and I think that will depend a lot into how open the companies that develop the environments are. So in this case, if I don't know if FrameVR accepts FBX files or GLTF files, which are open standard files. Well, I mean FBX is owned by Autodesk, but there are files that are cross-platform. Then it will work in FrameVR. But if there are platforms like Sandbox, for instance, that they have their proprietary formats, there's very little we can do to make interoperability happen. So I guess when we're developing systems, it's really being an advocate of open standards and try to develop our systems in such a way, and then try to get the companies that are not so open standard, I guess, to try to move towards it. because that's the only way on how once we create our identity, we can take it from platform to platform. I mean, there's much more involved into it, right? Like authentication and so on. But at a high level, I guess that would be something to really think about. Is at our end, we use standard files. Then, which is the standard files that other companies um, allow? That would be answering one of the questions of the chat.
Yes, we do have some questions here on the chat. So some of them are very specific, like asking if the demo avatars can be used in other environments. I think that can be quickly, but I would like to bring to fore a recent question by Leandro, challenging, which is, how long do you think a fully functional metaverse can be created? And it does bring some social issues as individuals. So how legitimate are the concerns? So I think Leandro, starting this conversation, I think Leandro is perhaps referring to the kind of dystopian environment that Ready Player One showed, where people were isolated on their trailers, just completely moving into this virtual space. And to be honest, I've seen these concerns before. Every new round of technology brings it. I've seen these concerns when the internet started to appear. I've seen these concerns before the internet, when people were spending lots of time on computers doing non-network games, just games without any network, but spending a lot of time in games. Heck, I've seen my grandparents worried in the 70s that I was spending too much time reading physical books. They thought I might end up like Don Quixote in the famous novel that loses his mind after reading too much books. So every change from society brings similar concerns. And of course, some of those concerns materialize and some don't. But let's be honest, human society has at the moment 8 billion, American billions of individuals as of this week. It's such an immense variety of people that it's chaotic. So it's very hard to predict that it will be any kind of scenario for everyone. We will keep evolving as a society in many different ways. Regarding how long, to be absolutely honest, it can take 5 years or 50, because look back, just make this exercise and look back 10 years. 10 years from where we are now, and then 10 more. If you look 10 years, things didn't change much, apparently, to 2010 or 2012. But on the other hand, things that we are doing comfortably, like these teleconferences here, was shied upon. People refrained from using it. And then you 4 years, and suddenly 2002, gosh, people were discussing whether web forms was the proper way to submit online services. So in a mere 10 years, nothing seems to change. And in 20 years, it's immense. It really depends on much more than technology. It does much more on technology. And I think that's a challenge for these companies, like the one that hosted us. Fridolin and Veronica, pass on to you.
I have some thoughts on that. So first of all, I will not answer the question of when, because you can only be wrong, right? But I think it's somewhere in between yesterday and never. I think the metaverse is happening already in large parts. So we're talking about a silent technological revolution that has reached levels of outreach where people can participate, where the barriers for everyone are not that high to actually participate. And yes, we would like to see more smart glasses. We would like to see environments fitted with more sensors. We would like to have more data, more, which maybe tomorrow, in 10 days or in 50 years, that's really difficult to predict. I think the question as an industrial participant and as a consumer are not that far apart. I think for an entity the pressure to deliver in that space. So I think if you haven't been thinking about what your benefits in the metaverse could be and how you can make use of this new technology, you should. And there are certain benefits that you can reap today, even if you're looking at more expensive devices. So the possibilities you have of applying these technologies for knowledge exchange, for reduction of error, for increasing precision, for increasing safety, for guidance, for many other use cases are fantastic and fabulous and need to be used. And you can see that with the increasing activity in that space, that I think we're reaching saturation levels where almost every company says they are doing something, and it's now a space of laggards and late majorities to join up. In the consumer space, I think it may be a bit different because some of the hardware is still quite pricey. And then again, it's pricey because they are not sold in the billions like mobile phones. Theoretically, smart glasses are cheaper than mobile phones. They require less battery than mobile phones, and. But its scale-down versions are available on contemporary hardware. Use cases are plenty. Games, entertainment, learning are there. It's possible to use this technology now and gain the digital skills required to benefit from these technologies in the future as well. So, yesterday or never.
If I can add, and also addressing a few of the questions here, there are companies that they saw that creating a metaverse by itself is really, really complex, because if we think about it, it's kind of like doing a game with forgetting about the whole game mechanics, of the game. It's just creating a virtual world, and that's a lot of content to put in. So there are companies that are building automatic systems to build metaverses based on specifications, because they saw a niche. And then there are many other companies that what they're doing is they saw also an opportunity. So for instance, they're just specializing on creating houses or buildings, right? Or stores, and they're just commercializing the creation of that content. And if we carefully look at it, we're always talking about content, because there are not enough artists, 3D artists in the world that can address the need for creating content. And we can even look at it from a very niche, for instance, in retail. If you want to do virtual try-on experiences, the brands are trying to have a foot into these virtual worlds, into the metaverse, without really understanding what they're, that this is going to sound really bad. I'm just trying to find the right word so I'm more diplomatic. They're experimenting, okay, without really tackling the key problem, for instance, in retail, which is the returns that people have, because when they buy 4 of the same thing and they return 3 of all. So there is a discrepancy between the reason why they're building the technology and the stores for the metaverse and the actual problem, which is the return. Okay, so I think we're still in an exploratory way when building experiences. So another really good point to think about is, okay, the experience. Why are we building the experience we're building? Okay, and then you have a lot of companies that are developing technology, us included. We're creating, we're working really hard into building digital humans. And then you have the issue, which is a technology in search of a problem, right? So you can be in this very awkward space because you continue developing features for a market that still don't really know what they're going to be using it for. So I think what is really important is, just to step back a little bit, and at least that's what we do at Didimo, is, we're iterating constantly, and we do product-led growth, which is we incrementally build new features and we tested it in the market with the hope of really finding out exactly the need. And for instance, creating non-playing characters or NPCs and building the asset feature is actually solving specific problems. So I think it's really worth for everyone here listening is why are you building the technology you're building, and which is the experience that's going to be around a specific problem that actually needs to be solved. That's my 10 cents of. based on what we've been doing.
Okay, we still have questions, but now I have a personal problem because this was scheduled until 4 p.m. and I'm now running into a different meeting.
Me too.
As good as they are, they do lock us in. So I answered a few questions already here on the chat. There are a few for Veronica, like when will be the IPO of Didi will be. But I do have to leave, so I'm going to pass the role of managing this discussion to Fábio. Thank you, Fausto.
Thank you, Lionel. In fact, I was just about to ask kindly for us to close because we are going over time. So I will take the chance to thank you again for this very wonderful presentation. I just hope that everyone feels so pleased with it as I did, and let's hope we meet again soon for some more steps into Metaverse and all these wonderful technologies around it. I think I will just want to leave a final note. This was the last of this year for Altice Labs, but we will be back next year. And meanwhile, my colleague Fernando Morgado will soon, I think, pass the link for a quick survey that we would appreciate that participants will fill in. It's just a short survey. So thank you again, especially our kind guests. It was nice to have you.
Thank you, Fausto. It was really special. Really, thank you for the invitation. Bye, everyone. Thank you.
Bye.
Bye.
Bye. Bye.